Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope you all will be fine. In the last lecture, we have discussed the theory of operation of real single-phase transformers. The magnetization current in a real single-phase transformer and the equivalent circuit of a transformer. In this lecture, we will have a look at the concept of determining the values of components in the transformer model, that is open circuit test and short circuit tests of the transformer. So basically testing is done to determine the certain parameters of the transformer model. The approximate equivalent circuit of the transformer referred to the primary side is shown here. As we have already discussed the approximate equivalent circuit of the transformer in the last week lectures. As you can see in this diagram, there are different types of parameters. The parameters are RC, XM, R equivalent, X equivalent, where R equivalent is basically equal to Rp plus A square into Rs. Rp means primary resistance and Rs means secondary winding resistance, and A means turn ratio. We can determine the value of turn ratio by using this relation. As we know, A is equal to Np over Ns is equal to Vp over Bs. By using these relations, we can determine the value of A. And X equivalent is equal to Xp plus A square into Xs, where Xp is the primary reactance and Xx is the secondary leakage reactance, and A is the turn ratio. As we have already discussed in detail these relations in the last week lectures. So there are two types of testing of transformer. The first one is the open circuit test and the second one is short circuit test. We perform the open circuit test of the transformer to determine the values of RC and XM. As you can see in this circuit, this is the RC and this is the XM. To determine the values of RC and XM, we perform the open circuit test of the transformer, and we perform short circuit test of the transformer to determine the values of R equivalent and X equivalent. As you can see in this circuit, this is the R equivalent and this is the X equivalent. To determine the values of R equivalent and X equivalent, we perform the short circuit test of the transformer. Usually we do the open circuit and short circuit test under no load condition. It means we perform the open circuit test of the transformer and short circuit test of the transformer under no load condition. That is, when there will be no load connect across the secondary side of the transformer, then we will perform the open circuit test and short circuit test of the transformer. It means when there will be no external load connected across the secondary side of the transformer, then the power consumed in the transformer will be losses. The losses due to voltage is called core losses or iron losses of the transformer, and the losses due to current is called copper losses of the transformer. Normally we do the open circuit test to determine the core or iron losses of the transformer, and we perform the short circuit test of the transformer to determine the copper losses of the transformer. Now, first of all, we will discuss the open circuit test of the transformer. As we have already discussed, open circuit test of the transformer is basically used to find the values of RC and XM. RC is the core loss component and XM is the magnetizing component. So, to determine the core loss component and the magnetizing component, we perform the open circuit test of the transformer. Now, the question is, how will we perform the open circuit test of the transformer? In open circuit test of the transformer, we keep the secondary side of the transformer open. As you can see in this diagram, this is the primary side of the transformer and this is the secondary side of the transformer. In case of open circuit test, we keep the secondary side of the transformer open and apply the rated voltage at the primary side of the transformer. It means in primary side we will apply the rated voltage of the transformer. So, as you can see in this diagram, this is the rated voltage across the primary circuit and the secondary circuit is open. So the primary and secondary, there are two windings. Let the voltage ratio of the transformer is 380 ratio 11 kV. 380 volt ratio 11,000 volt. The first value, that is 380 volt, is the primary voltage and the second value, that is 11,000 volt, is the secondary voltage. In ratio, the first value is basically shows the primary value and the second value is basically shows the secondary value. So let the primary voltage is 380 volt and the secondary voltages are 11,000 volts. So by comparing these two voltage values, this is that is 380 voltage is basically less than the 11,000 voltage. It means the primary voltage is less than the secondary voltage. The less value of the voltage is called the low voltage and higher value is called the high voltage. It means according to this ratio of the transformer, the primary side is low voltage side and the secondary side is the high voltage side of the transformer. So we usually do the open circuit test at low voltage side of the transformer. This is very important point. We perform the open circuit test of the transformer at the low voltage side of the transformer. It means, first of all, we will determine the low voltage side of the transformer. According to this ratio, the low voltage side of the transformer is primary side and the high voltage side of the transformer is secondary side. So the condition for open circuit test is, we normally perform the open circuit test at low voltage side of the transformer. It means we will perform the open circuit test according to this ratio at primary side of the transformer. Ratio can be different. In case of step down transformer, primary voltage will be high and secondary voltage will be less. In case of step up transformer, secondary voltage will be high as compared to the primary voltage. So this is a very important point. for open circuit test of the transformer. Now the question is, why do we perform the open circuit test at low voltage side of the transformer? Because it is easier to handle the low voltage rather than high voltages. As you can see in this relation, we can supply 380 volt easily rather than 11,000 volt. So this is the reason number 1. We perform the open circuit test at low voltage side of the transformer. And the second reason is that the measurement of current is more accurate due to higher value in low voltage side. As we have already discussed, the relationship between primary voltage and primary current is inversely proportional, and the secondary voltage and the secondary current is inversely proportional as well. It means when the value of the voltage across the primary circuit will be more, then the value of the current across the primary circuit will be less. And similarly, when the voltage across the secondary circuit of the transformer will be high, then the current across the secondary circuit will be less. So, as you can see in this relation, the low voltage side is the primary side. It means the value of the primary circuit is low. And as we know, the relationship between the voltage and current is inversely proportional. When the value of the voltage will be low, then the value of the current will be high in the primary circuit. And as you can see in this relation, the value of the voltage across the secondary circuit is high. It means the value of the current across the secondary circuit will be low. So that's why we perform the open circuit test of the transformer at the low voltage side of the transformer. So, as you can see in this diagram, the secondary side of the transformer is open. That is, there is no load connected. In case of open circuit, current will be approximately 0 and voltage will be maximum. That's why wattmeter only show the core losses of the transformer. It means in open circuit, it means there is no load. Open circuit is also called no load. When there will be no load, it means the power consumed in the transformer should be 0. If the power consumed in the transformer is not 0, it means there are losses. Now, the circuit is open. The value of the current is 0. It means there is no current and the value of the voltage will be maximum. It means the power consumed in the circuit is basically losses due to voltage, because the circuit is open. When the circuit will be open, then the value of the current will be 0. When the value of the current is 0 and the voltage will be maximum. When the value of the voltage will be maximum, it means the losses in the transformer will be due to voltage only. So this losses is called the core or iron losses of the transformer. It means when we will perform the open circuit test of the transformer, we will find the core or iron losses of the transformer. So in open circuit test, we neglect the series components, that is R equivalent and X equivalent. As you can see in this equivalent circuit, in open circuit test, we will neglect the series elements, that is Rp, Xp, A square Rs and A square into Xx. The reason is that in case of open circuit, the value of the current will be 0. When the value of current will be 0, then there will be no drop across the series elements because the value of the current is 0. So in case of open circuit, we neglect the series components, that is R equivalent and X equivalent, because in case of open circuit, the value of the current will be 0 or very small. Due to this, we will neglect the series components, that is Rp, JXP, A square into Rs and JA square into Xs. So first of all, we will measure the open circuit power by using the wattmeter. As we know, in case of wattmeter, there are 3 points. This is the common point and this is the CT point of the wattmeter and this is the PT point of the wattmeter. We connect the PT point of the wattmeter with neutral point and the CT point of the wattmeter with the live wire. So this is the common point of the wattmeter. By using wattmeter, we can find the open circuit power or core losses or iron losses of the transformer. So as we know, the voltmeter is basically show the open circuit voltage of the transformer and ammeter is basically will show the open circuit current of the transformer. That is, this will be the V open circuit, this will be the current open circuit and this will be the power open circuit. So these 3 values we will determine by using open circuit test of the transformer. By using the open circuit test of the transformer, we can determine open circuit power by using wattmeter, open circuit voltage by using voltmeter and open circuit current by using ampere meter. So as we know, the open circuit power or P core will be equal to V open circuit I open circuit into cos theta. Theta is basically the angle between voltage and current. That is, the phase difference between voltage and current is theta. The value of theta we can determine, as we know, cos theta will be equal to P open circuit over V open circuit into I open circuit. And the value of the theta will be equal to cos inverse P open circuit over V open circuit into I open circuit. So we can determine the value of theta by putting the value of P open circuit, V open circuit and I open circuit in this formula. And as we know, the reciprocal of the resistance is called the conductance and the reciprocal of the reactance is called susceptance. And the third term is the reciprocal of the impedance is called the admittance. Admittance is basically the reciprocal of the impedance. And susceptance is basically the reciprocal of reactance. And the conductance is basically the reciprocal of the resistance. So we can determine the value of conductance, susceptance and admittance by using these 3 relationships. So admittance will be equal to conductance minus J into susceptance, or simply, as we know, the value of the GC is 1 over RC. Putting the value of GC in this equation, we will get YE is equal to 1 over RC minus the value of B is 1 over XN. It means the overall value of the admittance will be equal to 1 over RC minus J 1 over XN. Just putting the values of GC and BM from these 2 equations into this equation. So we get YE is equal to, that is admittance will be equal to 1 over RC minus J 1 over XN. So our main objective is to determine the values of RC and XM. As we have already discussed, by performing the open circuit test of the transformer, we basically measure the values of RC and XM. So First of all, we will measure the magnitude of the admittance. As we know, admittance is the reciprocal of the impedance, and as we know, impedance is basically equal to V open circuit over I open circuit. So the reciprocal of V over I is the I over V. This is the impedance, and the reciprocal of the impedance is called the admittance. Therefore, admittance, the magnitude of the admittance will be equal to I open circuit divided by V open circuit. And the value of the theta we will determine, as we have already discussed. The value of theta we can determine by using this formula, that is theta is equal to cos inverse P open circuit over V open circuit into I open circuit, as we have already discussed this formula. So putting the value of theta and the magnitude in this equation, we will get the real part plus imaginary part. This is the polar form, and we can convert this form into rectangular form. So if we convert this polar form into rectangular form, then let the value of this polar form will be equal to x plus jy. X plus jy is called the rectangular form. So we can convert polar form, that is r theta, into rectangular form. So let this is the rectangular form, x plus jy. So putting the value of I over V angle of minus cos inverse power factor is equal to x plus jy in this equation, we get x plus jy is equal to 1 over RC minus j 1 over xm. By comparing these two equations, we will compare real part with real part and imaginary part with imaginary part. Therefore, 1 over RC will be equal to x and 1 over xm will be equal to y. Just comparing the real part with the real part and imaginary part with the imaginary part. And the value of the RC will be equal to 1 over x. Just cross multiplication of this equation, we will get the value of RC will be equal to 1 over x, and the value of xm will be equal to 1 over y. It means just putting the value of x and y in this equation, we can determine the values of RC and xm. So the power factor is always lagging for a real transformer due to magnetizing components. So the angle of current always lags the voltage by theta. So that's why this is the minus sign. Minus sign basically shows that the current is basically lags the voltage. When the current will be lag, then the angle of the current will be negative. So in case of inductor, current is basically lagging the voltage by 90 degree. When the current will lag, then the angle of the current will be in the minus. Let the angle of the voltage is 0 and current is lagging. It means the angle of the current will be less than the 0. So that's why this is the minus sign. So by using these equations, we can determine the values of RC and XM. So this is the open circuit test. So this is the concept of open circuit test of the transformer. And now we will discuss the short circuit test of the transformer. As we have already discussed, we perform the short circuit test of the transformer to determine the values of R equivalent and X equivalent. Now the question is, how will we perform the short circuit test of the transformer? In short circuit test, we short the secondary side of the transformer and applied the voltage at the primary side of the transformer, and the applied voltage will be variable voltage because the secondary side in case of short circuit test is short. When if we will apply the rated voltage across the primary side of the transformer, then the current will be maximum. When the current will be maximum, then the winding of the transformer can damage. So that's why in case of short circuit test, we will perform the variable voltage source or across the primary side of the transformer. So the diagram of connection for transformer short circuit is shown here. As you can see in this diagram, this is the secondary side of the transformer and this is the primary side of the transformer. Secondary side in case of short circuit is short and we will apply the variable voltage across the primary side of the transformer, and this wattmeter will measure the short circuit power and this voltmeter will measure the short circuit voltage and this ampere meter will measure the short circuit current and this wattmeter will measure the short circuit power. As in short circuit test, we will apply reduced voltage because the secondary side is short. We will change the voltage up to rated secondary current. It means we will vary the voltage up to that point where the rated current will flow across the secondary circuit of the transformer. In short circuit test, the low voltage side of the transformer is short circuited and the high voltage terminals are connected to the variable voltage source, as you can see in this figure. In case of short circuit test, we normally perform the short circuit test at high voltage side, and low voltage side we will short the low voltage side and we will apply the variable voltage source at the high side of the high voltage side. It means we perform the short circuit test at high voltage side of the transformer. So when the value of the current will be maximum and the value in case of short circuit, as we know, in case of short circuit the value of the voltage will be very small or approximately 0. When the value of the voltage will be 0, then we can neglect the parameters RC and XM, because in case of short circuit the value of the voltages is very small. In case of small voltage or nearly 0, we can neglect the RC component and XM components. So that's why in short circuit test we neglect the RC and XM and we only determine the values of R equivalent and X equivalent. The losses due to short circuit or due to current is called copper losses. It means in short circuit test, when the voltage will be 0, current will be maximum, it means the losses in the transformer or the power consumed in the transformer will be only due to current because the circuit is short. When the circuit will be short, then the voltage will be minimum or approximately 0. When the voltage will be 0, current will be maximum. It means the overall power consumed in the transformer will be only due to current. And the losses due to current is called the copper losses of the transformer. It means in case of short circuit test, we determine the copper losses of the transformer. So the measurement is normally done in case of short circuit on the high voltage side of the transformer. It means first of all we will determine the high voltage side of the transformer, and the short circuit test we normally perform at the high voltage side of the transformer, and low voltage side we will short the low voltage side and we will apply the variable voltage source at the high voltage side of the transformer. And so as we have already discussed, since the input voltage is so low during the short circuit test, negligible current will flow through the excitation branch, that is through the RC and XM. That's why we neglect the RC and GXM or excitation branch in case of short circuit, and we only determine the values of R equivalent and X equivalent. So by performing the short circuit, as we have already discussed, the value of the cos theta, as we know, P short circuit is equal to V short circuit into I short circuit cos theta. By using this relation, we can determine the values of cos theta. The value of cos theta will be equal to P short circuit over V short circuit into I short circuit. And the value of the theta will be equal to cos inverse P short circuit over V short circuit into I short circuit. And as we know, the formula of the impedance is impedance Z will be equal to V short circuit over I short circuit. And also, as we know, impedance is equal to R equivalent plus J equivalent, JX equivalent. And putting the value of V short circuit and I short circuit in this equation, we get impedance equivalent is equal to V short circuit angle of 0 degree and I short circuit angle of minus theta. As we have already discussed, minus is basically shows the lagging current. The current in the transformer is basically lagging the voltage. When the current will lag, then the angle of the current will be less than the 0. If the angle of the voltage is 0, then the angle of the current will be less than the 0, because in transformer current lags the voltage. So that's why this is the minus sign. So by using this formula, if we take the angle in the denominator, then the sign of the angle will change. It means if the sign of the angle in the denominator is minus, if we will take the angle in the numerator, then the sign of the angle will change. So therefore, Z equivalent is equal to V over I into angle of theta. As we have already discussed, if we will take the angle from denominator to numerator, then the sign of the angle will change. And similarly, this is the polar form of the impedance. We can convert this polar form into rectangular form. So in rectangular form, the values in the form of x plus jy. This is called the rectangular form. This is called the polar form. So polar form we can convert into rectangular form. First part is the real part and the second part is the imaginary part. As we know, Z is equal to R equivalent plus JX equivalent. So this is also the impedance formula. And this will putting the value of Vs short circuit over I short circuit angle of theta is equal to x plus jy. In this equation, as we know, this is also equal to R equivalent plus Jx equivalent. Putting the value of V over I angle of theta is equal to x plus jy in this equation, we get x plus jy is equal to R equivalent plus Jx equivalent. Now, by comparing the real part with the real part and imaginary part with the imaginary part, we get R equivalent is equal to x and x equivalent is equal to y. So, by performing the short circuit test of the transformer, we can determine the values of R equivalent and X equivalent. So this is the short circuit test of the transformer. So now we will do the numerical problem related to open and short circuit test of a transformer. So the given data are, the first one is the open circuit test parameters. As we have already discussed, by performing the open circuit test, we determine the values of open circuit voltage, open circuit current and open circuit power. In case of open circuit, the value of the voltage will be maximum and the value of the current will be minimum. So as you can see in this data, in the given data, the value of the voltages is the maximum and the current is the minimum. So this is the open circuit power, that is 400 watt. As we have already discussed, the losses due to open circuit or due to voltage is called the core or iron losses of the transformer. So this is the core or iron losses of the transformer. And the parameter of the short circuit test is shown in this table. As you here, the short circuit voltage is equal to 489 volt and the short circuit current is basically given here 2.5 ampere and the short circuit power is basically equal to 240 watt. So as we have already discussed, in case of short circuit, the value of the current will be maximum and the value of the voltage will be minimum. So due to this, when the value of the current will be maximum, then the losses in the transformer is called the copper losses. So this is the copper losses of the transformer. This is the core or iron losses of the transformer and this is the copper losses of the transformer. These are the given parameters. And also given the value of the apparent power, that is S is equal to 20 kVA. This is the rating of the transformer. That is the rating of the transformer is 20 kVA and the voltage ratio is basically given in this numerical problem is Vp over Vs is equal to Np over Ns is equal to 8000 over 240. 8000 means the voltage across the primary side of the transformer. 240 means the voltage across the secondary side of the transformer, that is Vs. From this ratio, we can find the high voltage side of the transformer and the low voltage side of the transformer. It means the primary voltage is greater than the secondary voltage. So the high voltage side of this particular problem is the primary side of the transformer and the low voltage side is the secondary side of the transformer and the frequency is given here, F is equal to 60 Hz. Now the question is, find the impedances of the approximate equivalent circuit, refer to the primary side and sketch that circuit. It means we will find the values of RC, XM, R equivalent and X equivalent by using open circuit and short circuit test of the transformer. As we have already discussed, by performing the open circuit test of the transformer, we can find the values of RC and XM, and by performing the short circuit test of the transformers, we can find the values of R equivalent and X equivalent. So first of all, we will perform the open circuit test. The value of the parameters or the value of the parameters in case of open circuit is given here. It means open circuit test we have already performed. In this particular problem, the results of the open circuit test are shown here and the results of the short circuit test are shown here. So by using these results, by using the open circuit test results, we will find the value of RC and XM. By using the short circuit test results, we will find the values of R equivalent and X equivalent. So this is the numerical problem we will solve in this lecture. So first of all, we will use the open circuit test result and find the values of RC and XM. As we have already discussed, power factor, that is cos theta, is equal to P open circuit over V open circuit into I open circuit. Putting the value of P, V and I in this equation, we get the value of V is 8000, the value of the P is 400 and the value of the V is 8000 and the value of the I is 0.25 0.214. So the value of the theta will be equal to, theta is equal to cos inverse 400 divided by 8000 multiplied by 0.214. After solving this equation, we get 0.234. So the value of the theta will be 0.234. And lagging means, as we have already discussed in the transformer, current lags the voltage. So that's why we will write here lagging. Lagging means theta. The theta is basically, lagging means the angle of theta will be in the minus. So this is the value of the theta. So the value of admittance will be equal to, and as the value of the open circuit current is given here 0.214, and the value of the open circuit voltage is given 8000 volt. Angle of minus cos inverse power factor is basically, the angle of is basically given here minus cos. So angle is basically given here. Sorry, this is the value of the cos theta. The value of the cos theta is basically is equal to 0.234. And as we know, the cos theta is also called the power factor. So the value of the power factor is 0.234 lagging. So as we know, theta will be equal to cos inverse this value. So therefore, YE will be equal to 0.214 divided by 8000 angle of minus cos inverse 0.234. After solving this equation, we get admittance is equal to 0.0297 angle of minus 76.5 degree is equal to 1 over RC minus J 1 over XM. As you can see in this equation, YE also equal to 1 over RC minus J 1 over XM. So this value will be equal to 1 over RC minus J 1 over XM. So first of all, we will convert this polar form into rectangular form. Then we will compare the real part with the real part and imaginary part with the imaginary part. So therefore, first of all, we will convert this polar form into rectangular form. So we get 0.0069 minus J 0.0288 is equal to 1 over RC minus J 1 over XM. Now by comparing the real part with the real part and imaginary part with the imaginary part, we get the value of RC will be equal to 144 ohm, and the value of the XM will be equal to 34.63 ohm. So this is the value of RC and XM. We determine the value of RC and XM by using the results of open circuit test. So as we have already discussed, by using the results of open circuit test, we can determine the values of RC and XM. So now we will determine the R equivalent and X equivalent by using the short circuit test results. So similarly, in case of short circuit, as we know, power factor is equal to cos theta is equal to P short circuit over V short circuit into I short circuit. Putting the value of short circuit test result in this equation, we get the value of P short circuit is 240 watt divided by the value of V short circuit is 489 volt, and the value of I short circuit is 2.5 ampere. After solving this equation, we get the value of power cos theta is equal to 0.196 lagging. Lagging means the current is lagging and voltage is leading. So this is the value of the cos theta in case of short circuit test. So the series impedance will be given as Z is equal to V short circuit over I short circuit into minus cos inverse into power factor is equal to R equivalent plus J X equivalent. Putting the value of Vi and cos inverse power factor in this equation, we get Z short circuit is equal to, the value of V is basically 489 and the value of the I is 2.5 ampere, angle of minus cos inverse. The value of the power factor is basically 0.196. Putting the value of 0.196 is equal to R equivalent plus Jx equivalent. So this is the polar form. So first of all, we will convert this polar form into rectangular form. Then we will compare real part with the real part and imaginary part with the imaginary part. So after converting this polar form into rectangular form, we get 38.4 plus J192 is equal to R equivalent plus Jx equivalent. So after comparing the real part with the real part and imaginary part with the imaginary part, we get R equivalent. We get the R equivalent is equal to 38.4 plus X equivalent is equal to 192. So this is the value of R equivalent and X equivalent. So this is the value of X equivalent and this is the value of R equivalent. So as we have already discussed, we calculate or we can determine the value of R equivalent and X equivalent by performing the short circuit test of the transformer. As we know, we perform the short circuit test of the transformer at the high voltage side of the transformer. In this case, in the given problem, the high voltage side was the primary side. And we perform the open circuit test in the low voltage side of the transformer. In this case, in the given case, the low voltage side was the secondary side. It means in open circuit test, we determine the value of RC and XM in the secondary side of the transformer, and we determine the value of R equivalent and X equivalent in the primary side of the transformer. So this is the equivalent circuit in the primary side of the transformer. But in open circuit test, we calculate the RC and XM in the secondary side of the transformer. It means we convert these value into primary side. So therefore, RC primary will be equal to A square RC secondary. After solving this equation, we get 159 kilo ohm. And similarly, the value of XM primary will be equal to A square into XM secondary. After solving this equation, we get the value of XM is equal to 38.4 kilo ohm. So this is the value of RC in the primary side and this is the value of magnetizing component in the primary side. So putting the value of RC XM here and the value of R equivalent and X equivalent here. So this is the resulting equivalent circuit of the given problem. So the value of RC is basically 159K and the value of the XM in the primary side is equal to 38.4K. The value of R equivalent is 38.4 and the value of the X equivalent is 192 ohm. So this is the resulting equivalent circuit. We have just find the values of RC, XM, R equivalent and X equivalent by performing the open and short circuit test of the transformer. So this is the problem. This is the numerical problem relating to open and short circuit test of the transformer. So that's it for this lecture. In the next lecture, we will discuss the per unit system of the measurement.